Hey, what's going on, guys? Kumagigenzi here. In this video we're going to be dealing with a stack pointer, and the base pointer, and the stack segment. So what are those things, how they work, and why it's so important to set those properly? This is going to be the topic of this tutorial. So when I just started this series, I didn't really think that we're going to be kind of like relying on stack at all, but then it turned out that we started calling print string and things like that, and when we deal with the instructions like call, we actually do implicitly rely on stack, because the address word to return after the call has been printed, after the call has been fired, is stored on a stack. So that is a specific location in the physical memory, and it's really a good idea to know where exactly that specific location is. And every single tutorial and all the materials, all they suggest to explicitly set up stack. So usually stack is only being set up in the bootloader, and then it's used in the shell and everywhere else. But bear in mind the fact that we're going to be running the boot sector games, which in many cases boot sector games are setting stack on their own to wherever they want, because there is no specification. Like they are free to set the stack wherever they want. And in this, because of this, we're going to be setting the stack in the boot ASM and in the shell ASM. So every time the shell is getting reloaded, we reset stack back to make it work with our shell. And then, if needed, the game loaded into the boot sector would reset it to whatever value, to whatever place in physical memory once. Okay, so let's start by running our OS from the previous part. So just say run.shell, and here's what we got. Okay, so say snake, and we play, get back, and say breaks, we play. Okay, and probably not get back. Yeah, we wouldn't get back here, but well, that doesn't matter really now at the moment. So it seems like everything okay and everything is working, and it is literally, and it's not a big deal really, and it even works in real hardware, which would be demonstrated very soon. But I just want to show you guys my concerns. So let's close this one. I'm not sure, probably Camo also allows to get a memory dump, but I'm using this online emulator that is called copy.shell version 86. So another way of when we deal with these calls, we have no idea what kind of value is going to be stored there, but there are two good instructions, push and pop, that do explicitly rely on stack. So what push does, so it decrements the stack pointer, and by the way, in the x86 architecture, the stack goes downwards, not the upwards, but downwards. Hence this. So it decrements the stack pointer and then stores the source operand. So whatever we push to the stack, on the top of the stack, but to be more exact, it would be on the bottom of the stack. But well, just conceptually, it's on the top of the stack. Address and operand size determines and used. Okay, so this is it. So when we push something, this would be in the random access memory. So in order to figure out where stack is in the current emulator, because in this emulator it might be one place, in Camo it might be different place, another place on the real hardware it might be third place. So it doesn't matter really. I just wanna find where exactly that might be. So let's say here we just say push and hexadecimal, let's say AAAA, and then push, let's say BBBB, some values that would not otherwise be available in the memory dump, CCCC, and push, and ABCDDDD. Okay, and now we build this. Okay, and now let's open So go tutorials, part 9. We are within the part 9, right? Okay, so GameOS image, I'm running the image and starting the emulation. It runs, everything worked perfectly. So bootloader has loaded the shell, it's okay. And now we can have a look at the memory dump. Okay, so the memory dump would get now downloaded. So we go to the downloads. Okay, so just rename this to memory.bin and open terminal here, and I say xxd mem.bin, and we don't need the entire one, we just need the address of 00007C00, which is the address where the bootloader starts. And we will want to make our stack using this, starting from here and down below to as long as it goes. So that's the destination place. But now let's try to find where our data is actually. Yeah, by the way, if I didn't print the entire stack, it might not even be there. But anyway, let's try to search. So AAAA. Let's have a look. Okay, and here it is. So you see, like, here is the data. So let's just try to copy, find, paste. Okay. Okay, AAAA, find, it was, yeah, some other, yeah, but I guess this is it. I guess this should be kind of it. Oh, it just goes in the reverse order. Okay, so D, C. Okay, anywhere else? Nope. Yeah, doesn't seem that's available anywhere else. So, and again, like, so if we have a look at the address, it's somewhere 6F. Yeah, it's somewhere below, definitely somewhere below our bootloader, because the bootloader goes 7C00 here. So it actually it uses the stack is somewhere here. Okay. But we want the stack to be exactly here, just to make sure here, just below the boot sector, just to make sure that we exactly know where the stack is. Okay, so I hope this is clear, and we will do this both in the bootloader, just because we have a couple of call functions here, and in the shell to reinitialize stack every time we're gonna come back from the game. Like from the game, making far jump back to the shell. All right, so now let's okay, so yeah, sorry guys, I forgot to mention another thing. So in regards to stack, we have stack segment, and within the stack segment we have the stack pointer. So okay, just provide this visual representation apparently. So let's say stack. Okay, so you imagine just these are the memory cells, and let's imagine that here we have the address 7C00. Okay, and let's so here we have this, so here it is. Okay, yeah, and here the bootloader code starts from here to I just said once to give you an idea that here we have the bootloader code. Okay, so when we do push, what happens? When we do push, we first decrement the stack pointer and then store source operand on the top of stack. So let's say we want to make by the way, where is the did I just delete those pushes? Yeah, I did. Okay, so let's say I do like push like hexadecimal AAAA, right? So what happens? the stack pointer gets decremented, and this value becomes, it starts having this AAAA, okay? And then when I pop, if I then pop the value, so pop to, let's say, AX register, what would happen? It would just put this, take this value, and it would be like AX equals to this value, and then it would increment the stack pointer pointing to its initial place. Now the initial place where the so this V is known as the stack pointer, SP. So this is the stack pointer. Okay. So let's say we didn't push anything yet, we didn't pop anything yet. So this is the stack pointer, okay? And the initial place here, well, let's call it, let's make this again. So this is the BP, which stands for base pointer. Okay, so SP is the stack pointer, BP is the base pointer. So base pointer is the location in the physical memory from where it's kind of like the base of the stack segment, the floor, the bottom. So it's where it starts. So starting from there, it just gets incremented, and so this SP just moves along the way, and base pointer remains the same. So some techniques allowing to remember this base pointer, replace it somewhere, and that is used in order to simulate passing the arguments to the procedure, to the function, basically. But that's a completely different topic that takes, I don't know, it can be covered in many hours on its own, so we're not going to be touching this because we're not dealing with that. All we need is actually to initialize the stack segment, just like we did with DS and ES, the data segment and the extra segment, and then we need to set up the base pointer to the value of 7C00, because there is where our bootloader is loaded at, and then we need to set the stack pointer equal to the base pointer. That's pretty it. So let's go for it. So I need to say move, and as stack segment AX, so it would be 0, okay, but assuming the org 7C00, it's okay, just like the data segment and just like the extra segment. Okay, so here we want to set stack segment, let's make it segment to 0 from the capital. All right, then what? Then we want to set the base pointer, so move BP and hexadecimal 7C00, and here we have set base pointer, stack base pointer, stack base to hexadecimal 7C00, just right at the boot sector. Okay, and then we need to say move SP to SP, we move BP. So we just kind of like synchronize them. So base pointer, base pointer, stack pointer goes where the base pointer is. Then let's say we make push, increments, then pop, decrements. The same stuff happens with the call. So let's say call the function, increments, return, decrements, and so on. So that's how it works. Very rough kind of like explanation. All right, so here we want to set stack pointer to exactly the same to this value as well, by the way. All right, and that's pretty it. So I get rid of this weird stuff. This could be useful, but I just don't really want to keep it here in the code. All right, and just to give an idea of how this works, so let's say before anything else, before making any calls or something, let's just say push hexadecimal AAAA, and then push hexadecimal BBBB, then push hexadecimal CCCC. And now if we compile and run this, I'm sorry, not here. Now if we compile and run this, I mean assemble and run obviously, and then going back here, go back and choose the file, game image, load, start emulation. All right, sorry, it takes time, but I swear it's worth it because you really can visually see what's going on. Now downloading the memory dump back again. Okay, go into downloads, deleting the previous one, rename mem.bin, and here let's clear stuff. All right, and xxd mem.bin, and okay, and looking for 00007C00. all right, okay, and suddenly guys we have our values that we have been pushing here in the bootloader code being exactly being exactly in the place in the physical address memory where here where we wanted them to be. That's pretty. So now we know for sure where the stack is located, and that's really cool. Okay, so this is it for in regards to the bootloader basically, right? But we also want to make the same for so I just want to copy this. Okay, I want to get rid of this. Yeah, and here within the shell, here I want to paste the same code. So set in this stack segment. Okay. All right. I hope I don't have any tabs. Yeah, I don't. Okay. And let's say like like no, A, B, C, D. Let's start D, E, and F. Okay. So now we're gonna be pushing from the shell, and these are the values, and they should be exactly in the same place. So let's have a look. Okay, so I'm just running this stuff, closing. Go back, choose file, GameOS, open, start emulation. Okay, yeah, this all should be still working, right? Great. It's not that perfect yet in this emulator, but we'll fix this later on. Okay, so going for a memory dump, and get rid of this one. Rename mem.bin, clear, and xxd mem.bin, and find our location. And here we go. So we have DEF in the reverse order because this is a stack. First in, last out. Okay. So yeah. So D, F. So we did push D, E, F, and in stack we should have F, E, D. Okay, yeah, F, E, D. Just yeah, that's pretty it. So we did push this one, then this one, then this one. Yeah, this is pretty it, guys. So hold on a sec. 7C0. Oh man, hold on a sec. One more time. Yeah, here is where the boot sector starts. Okay. Yeah, and here we have our values. That's kind of pretty it. Well, okay guys, so yeah, this is kind of it regarding initializing the stack segment, stack pointer, and the base pointer. So people say it's a good thing to do so. I agree, right? Even though again I was working without this, but now hopefully it's just more like a better way of doing things, and it's easier to debug now, I believe. So if something goes wrong, we can have a memory dump and we know at least where to look at when it comes to stack, let's say. Okay, so now before we end this video, a few more clarifications, because I've spotted a few not very, but probably potentially confusing parts in the code. So let's also replace this by, call it boot sector address, right? Okay, shell address, files address, and let's take the first one, define the boot sector address, and here it is. Great. So this should still be working, right? Okay. And here is the deal, guys. So I call this boot sector address, but it's not essentially true, because this is the address and this number is not the same as this one. And as when I've been explaining how the physical address, when I've been explaining the formula to get the physical address from segment and offset, so we need to take the base segment, multiply by hexadecimal 10, and add the offset. So this is better to call, so Control F, Control H, so let's call it boot sector, not the address, but segment. Let's call it segment, and replace all. And I really hope it didn't break anything. Save, and I really hope this is still gonna be working. Okay, yeah, still capable of playing game. Right. Okay. And yeah, should be okay. All right, so this one boot segment address. However, we still need exactly the define boot sector address, and to set it to hexadecimal 7C00. Yeah, and now this is actually the physical memory address, while this is segment boot sector segment to make for jump to load. Boot sector segment address to make for jumps to load games. Yeah, it's just okay. And well, but we actually don't really use this address for loading games, we just use this one. And when we execute, we just go into this. Yeah, and by the way, it should be here as well. Okay. Yeah, okay. Okay. yeah, I just need to figure out what would be the better, how to specify the proper commentaries. Segment addressed. Let's say used for far jumps to execute boot sector games. And this is the physical memory address used for a base pointer, used as a stack, used by base pointer, used as a stack base pointers. Address, location, starting point. As stack pointers, starting point, or as stack base pointers, location. Okay, let it be. I'm sorry, guys. It's just probably I'm tired already. So physical memory address to the files. Address used as a stack base pointers. Used to init stack base pointer. That's pretty it. That's what it is. That's what it does. Physical memory address used to init stack base pointer. Okay, and now we are really done. So let's go for a final run. Okay, guys. So this is pretty it. Okay. Yeah. All right. So the next plans, we are very close to the final demonstration of how the operating system works, and the only thing left here that I want to deal with is I want to separate this list command, like the command to print all of the where is that? Print files. This one, I want to separate this into a different file, and I want to run this as it was a game. So it's going to be running in a boot sector as well. And the purpose of this program is to provide all kind of like games that we currently have. And this is going to be the topic of the next video. I think so. I hope so. So yeah, we'll see. Okay, guys, so this is it from my side. Thanks for watching. Until the next time, and take care.